Hey, welcome back. This is Max ADC with Abby, and we were dealing with set language in the last video and we are continuing it now. So if you haven't seen the last video, please check it out in the description or just click on the link given. So to summarize, what we have learned in the last video is that a set is a collection of well-defined objects. To add some more things, we will just give the definition of set as the set is a collection of well-defined distinct objects. The set well-defined distinct objects. Right. So why did I add this word distinct is that you can't have repetitions inside a set. So that's why I added distinct here. Then let's see what we are going to learn in this module. So we'll be learning representation of set, we'll be learning types of set, we'll be learning set operations and its properties, we'll be learning De Morgan's law, and we'll be learning applications on cardinality, that is real life problems using set. So we'll go on with representation of set in this video, and in the upcoming videos we'll be discussing all these topics. So we'll go on to representation of set. So a set can be represented in three ways. So the first one is descriptive form, the second one is set builder form or set rule form, and the third one is roster form. We'll discuss one by one. So we'll move on with the descriptive form. So descriptive form is nothing but defining a set with a normal language. So let's take for example, if you want to describe Bigil, the movie, the Tamil movie Bigil. So it's actually the collection of movies acted by Vijay in 2019, right? So if one wants to describe Bigil, he could put in this form. And likewise, if you want to describe Vivegam, so it's actually the collection of Ajit movies which was acted in 2017. So you can give the collection of Vijay movies in 2019 as a set called Bigil, and the collection of Ajit movies in 2017 can be called as Vivegam. So you are actually describing the set in a normal language instead of following the notations. So that's called as descriptive form. And moving on to set builder form, as the name suggests, you have to build the set with certain rules. So we'll just jot down one by one. So let's take the first example. It shows that it's the set of x such that x belongs to natural numbers. Obviously, we know that natural number starts from 1, 2, 3, 4 and it goes on. And yeah, this colon actually represents such that, right. So we are supposed to find x elements and we are given the nature of x, which is nothing but natural numbers. So natural numbers are 1, 2, 3, 4. We apply it to x and we have found the x elements. So this set can be represented as the set 1, 2, 3, 4, and it actually goes on infinitely. And the next one is the set of 2y such that y belongs to whole numbers, 0 is less than or equal to y is less than or equal to 4. So we are asked to find the elements 2y such that we are imposing a condition on y which should actually belong to whole numbers, and again a restriction on y such that the y must lie between 0 and 4. So we'll discuss a lot more in detail now. Let's take this one for now. So it suggests as 0 less than or equal to y less than or equal to 4, right. So we know that the whole number starts from 0 and we are given an less than equal to sign, so that 0 can be included in this interval. So it's actually 0 and 1, 2, 3, and we are nearing to the end point 4 and we are asked to include the end point 4 here. So I'll include here. So y takes the values 0, 1, 2, 3, 4. For instance, if we are given 0 is strictly less than y and it is less than or equal to 4, here we don't have the status quo here, so we have to omit the end point. So after 0, 1 comes in whole numbers. So 1, 2, 3, and we are asked to include 4 here by using the equal symbol. So I'll include 4 here. And it's the same case when it's 0 less than or equal to y is less than 4. We'll be omitting 4 here and adding 0 here. And if there was like 0 less than y less than 4, we'll be omitting both the endpoints. So we'll be having 1, 2, 3, and that's all. We won't have 4 here since we have to omit 0 and 4 here, right? So yeah, we have seen, we just now saw about the intervals, and for here the example is given as include the endpoints. So y takes the values 0, 1, 2, 3 and 4, right? So we are given y is equal to 0, 1, 2, 3, 4, and we can't stop up to that since we are asked the elements which are actually twice the value of y. So we have found y here, multiply each element by 2. So 2y is actually equal to 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6 and 4 times 2 is 8. So this set is actually 0, 2, 4, 6, 8. Let's now actually try to write this set in descriptive form. We have 0, 2, 4, 6, 8 here, which is obviously the even numbers less than 10. So we can write this particular set as the collection of even numbers which are less than 10. So eventually the definition given here and the descriptive form which I said now stands equal, right? So one can actually change the forms for describing a set. And the next one is roster form, explicitly mentioning all the elements in the set. That is, you will be mentioning each and every element belonging to the set, like I did here. So in the set builder form, we saw that this set is actually 0, 2, 4, 6, 8, and this set is 1, 2, 3, 4, 5, 6, the same which is as natural numbers. And in the descriptive form, we saw that here the collection of Vijay movies in 2019 is Bigil and the set Bigil, and the collection of Ajit movies in 2017 is set Vivegam. So instead of writing in descriptive form, I can write in the roster form too. This is how you interchange between the representations of set. Let's see one example. So we have the die example here. So you can represent this die D as the set of possible numbers in a die. So you have 0, 1, 2, 3, 4, 5, 6. So it is same as writing in a description. So D equals the set of possible numbers in a die, or you can write as D equal to X such that X belongs to die. That is, the numbers which are related to die is the elements of X, and we have to collect those elements, put it in this set. So X such that X belongs to die, it's nothing but 1, 2, 3, 4, 5, 6. And the third one is the roster form, which actually explicitly gives you the members of the set. Can you think of other way of describing this set? Can you think of any other possibilities? Yes, you can. So you can give as D equal to the set of X such that X belongs to natural numbers, and we impose the condition on natural numbers such that X actually must belong from 1 to 6. So the set die could be represented in this form, in this form, in this form, or in this form too. There is no restriction in you have to represent a set in this way alone. So you can use any definitions, but it has to be well defined. That's the basic concept of set. So there is no restriction in defining a set, but it has to be well defined. So to summarize, what we have learned here is a set is a collection of well-defined distinct objects, and we saw the rules for writing set, and we saw a set can be represented in three ways, like descriptive form, set builder form, or set rule form, or in the roster form. So that's all for set. We'll be seeing in detail about set in the next video. Bye bye, take care.